Hello everyone, welcome to our online video tutorial series, and in this video lecture we will learn about class 11 maths trigonometric functions. Today we will solve miscellaneous exercise of NCERT textbook. So let's start our today's class. So before we start, let's revise few very important identities which we will use in this video lecture. The first is S plus S is equal to 2SC, which means sine theta plus sine phi is equal to 2 sine theta plus phi by 2 cos theta minus phi by 2. Second identity is S minus S is equal to 2CS, which means sine theta minus sine phi is equal to 2 cos theta plus phi by 2 and sine theta minus phi by 2. Next is C plus C is equal to 2CC, which means cos theta plus cos phi will be equal to 2 cos theta plus phi by 2 cos theta minus phi by 2. And the next is cos theta minus cos phi, which is minus 2 sin theta plus phi by 2 sin theta minus phi by 2. Let's solve the problems based on these four identities. So our first sum is we have to prove that 2 cos of pi by 13 cos 9 pi by 13 plus cos 3 pi by 13 plus cos 5 pi by 13. So here this first term is in the factorized form and these two terms are in the defactorization form. So what we will do, either we will defactorize them or we will factorize this part. So one of the method we will apply so that the terms will look alike. So I am going to do the factorization method. So first of all 2 cos pi by 13 cos 9 pi by 13, and I will do the factorization of cos 5 pi by 13 plus cos 3 pi by 13 is equal to 0. So for this part I am going to do the factorization. So this will be an identity of cos theta plus cos phi, which is 2 cos theta plus phi by 2 and cos theta minus phi by 2. So my theta will be equal to 5 pi by 13 and value of phi will be 3 pi by 13. So it becomes 2 cos pi by 13 cos 9 pi by 13 as it is, and then apply this identity. So it becomes 2 cos 5 pi by 13 plus 3 pi by 13 by 2 and cos 5 pi by 13 minus 3 pi by 13 by 2. On simplification you will get 8 pi by 13 by 2 and here you will get 2 pi by 13 by 2, which is equal to 2 cos pi by 13 cos 9 pi by 13 plus 2 cos 4 pi by 13 cos pi by 13. So now if you observe, this is 2 cos pi by 13, this is 2 cos pi by 13. The only these two terms are distinct. And if I have to prove that this is equal to 0, that means I have to cancel them. It means these angles, if you observe carefully, are the supplement angles. So 9 pi by 13 plus 4 pi by 13 is equal to pi. That means they are supplementary angles. So what we will do, we will replace one of the identities with another one. See how? I will change this cos 4 pi by 13 as, can I write as cos pi minus 9 pi by 13. Pi minus 9 pi by 13 is again 4 pi by 13. So cos pi minus theta. Cos pi minus theta is quadrant number second. And in second quadrant, that cos will be negative, so minus sign. And as we are measuring the angle with respect to pi, so as it is cos 9 pi by 13. That means cos 4 pi by 13 can be replaced with minus cos 9 pi by 13. And that was what I want. So let's replace here in equation number 2. Let's replace that. So it will become 2 cos pi by 13, 9 pi by 13 and minus 2 cos, see this I replaced, plus 2 cos 4 pi by 13 with minus 2 cos 9 pi by 13 and cos pi by 13, and you see that these two will cancel, so it will be equal to 0, which is right hand side. Next is sin 3x plus sin x into sin x plus cos 3x minus cos x into cos x. So let's expand this bracket first. So it will become sin 3x plus sin x into sin x and cos 3x minus cos x into cos x. So if I expand the bracket, so I have to multiply cos 3x with sin x and sin x with sin x. So it will become cos 3x sin x and sin x into sin x. And here it will become cos 3x into cos x minus cos square x. Now just rearrange them. This cos 3x cos x I wrote first, then sin 3x sin x, then minus cos square x, and then plus sin square x. Why I rearranged? Because this part look like an identity. Cos x cos y plus sin x sin y. And this is also looking like an identity. If I take negative common, it will become cos square x minus sin square x, which is equal to cos 2x. So let's do that. So we know that cos x minus y is cos x cos y plus sin x sin y. So this will become cos of, this is x and this is y here. So 3x minus x. So it will become cos 3x minus x minus, and if I take the negative common from these two, it will become cos square x minus sin square x. And as we discussed, cos 2x is equal to cos square x minus sin square x. So let's put the value. This will be equal to cos 2x. So cos 2x minus cos 2x will become 0, which is correct, hence proved. Our next sum is cos x plus cos y whole square plus sin x minus sin y whole square. And we have to prove this is 4 cos square of x plus y by 2. So dear students, what we have to do, we have to observe it carefully. See, here my angles are x and y in both the terms. But in my answer, I need x plus y by 2. So how I'll get that x plus y by 2? That means I will apply these two identities, that cos theta plus cos y, which is 2 cos theta plus phi by 2 cos theta minus phi by 2. And second identity for this part, sine part, I will apply sine theta minus sine phi. So let's put the values and I will get 2 cos x plus y by 2 cos x minus y by 2 whole square plus 2 cos x plus y by 2 and sine x minus y by 2 whole square. So now if you observe that this 2 is common in both the terms, so 2 square will be common. Cos x plus y will be common. So let's take them common. So it will be 2 cos of x plus y whole square will be common, and the remaining terms will be cos of x minus y by 2 whole square and sine square of x minus y by 2. And as we know that sine square theta plus cos square theta is equal to 1. So here it is the same thing. Sine square, this is theta, cos square theta, because the angles are same, so this will be equal to 1. So what is left here? 2 square will be 4 cos square x plus y by 2, and this will be 1. So if I multiply with 1, I will get my answer, which is right hand side of the equation. Next is sin x plus sin 3x plus sin 5x plus sin 7x, and we have to prove that this is equal to 4 cos x, cos 2x and sin 4x. So left hand side is in the defactorized form and right hand side is the factorized form. So what we will do, we will do the factorization of this term. So let's do the factorization, and before that let's rearrange them. See, this is x, this is 7x, total will become 8x, and 3x plus 5x will become 8x. So it's very important to arrange them, and we will apply here this identity, that sine theta plus sine phi, which is 2 sine theta plus phi by 2 cos theta minus phi by 2. So let's rearrange them and apply the identity. So rearrange them, sine 7x plus sine x and sine 5x plus sine 3x. And this will become sine theta plus sine phi. This is theta and this is phi. So sine theta plus sine phi is 2 sine theta plus phi by 2, that is 7x plus x by 2, and cos 7x minus x by 2. Similarly, the same property will apply there also, sine of 5x plus sine 3x. So if I apply this CD formula here, so it will become 2 sine 5x plus 3x by 2 and cos 5x minus 3x by 2. And let's simplify them. 7x plus x will become 8x. 8x by 2, it will become 4x. 7x minus x will become 6x. 6x by 2, it will be 3x. This is again 8x, and 8x by 2 will be 4x, and 5x minus 3x by 2 will become x. So let's write it, 2 sine 4x cos 3x plus 2 sine 4x and cos x. Now I can take common 2 sine 4x. from both the terms. So let's take it common. So 2 sine 4x I had taken common. It will become cos 3x plus cos x. Now I'll apply the second identity, that cos theta plus cos phi, which is equal to 2 cos theta plus phi by 2 and cos theta minus phi by 2. So theta will be 3x and phi will be x. So it will become 2 sine 4x, 2 cos 3x plus x by 2 and cos 3x minus x by 2. And if I simplify, this 3x plus x will become 4x. 4x by 2, that is 2x. And 3x minus x will become 2x and 2x by 2 will become x. Write it as 2 to the 4 cos x, cos 2x and sin 4x, which is the right hand side which we have to prove. See, this side we have so many terms having addition sign in the numerator as well as in the denominator. But my answer is a unique term. That means I have to factorize them to get them cancelled. So which two identities will you use here? See, one I need that sine theta plus sine phi. And another I need is cos theta plus cos phi. So let's write both the identities, sine theta plus sine phi and cos theta plus cos phi. So in the first part, if you see, 7x will become my theta and 5x will be phi. So it will become 2 sine 7x plus 5x by 2 cos 7x minus 5x by 2. And sine 9x plus sine 3x will become 2 sine 9x plus 3x by 2 and cos 9x minus 3x by 2. And in denominator, it will be cos theta plus cos phi, which is 2 cos theta plus phi by 2 and cos theta minus phi by 2. And in the second part, it will become 2 cos 9x plus 3x by 2 and cos 9x minus 3x by 2. So here I applied this second identity. And now let's simplify. 7x plus 5x will become 12x. 12x by 2 will be 6x. And this will be x. Again 12x by 2, 6x. And 9x minus 3x, 6x divided by 2 will become 3x. So let's write the simplified form. 2 sine 6x cos x plus 2 sine 6x cos 3x. And in denominator, 2 cos 6x cos x and 2 cos 6x plus cos 3x. So now if you look at the numerator and denominator carefully, here 2 sin x is sin 6x common in numerator and in denominator 2 cos of 6x common. So let's take them common. So if I take 2 6x common from the numerator, it will be 2 6x into what will be left? Cos x, and this side cos 3x. And in denominator, if I take 2 cos 6x common, it will become cos x plus cos 3x. And as you can see, they are equal, so cancelled. 2 and 2 cancelled, and sin 6x by cos 6x will become tan of 6x. Next, again based on the factorization identity, just rearrange them. Sin 3x minus sin x, because their mean value will become 2x. So sin 3x minus sin x plus sin 2x. So by arranging the terms, make our sum very easier. So which identity I have to apply here in the first? This is sin theta minus sin phi, which is 2 cos theta plus phi by 2 sin theta minus phi by 2. So let's get the value. 2 cos 3x plus x by 2 and sin 3x minus x by 2 and plus sin 2x as it is. So 3x plus x by 2 will become 2 cos 2x. 3x minus x by 2 sin x plus sin 2x. Now nothing is common between these two terms. So what we will do, we will expand this sin 2x. That will help us to get the 2 also. And as you know, sin 2x is 2 sin x cos x. So let's put the value of sin 2x here. 2 sin x cos x. Now I can take 2 sin x common. So let's take 2 sin x common. And it will be cos 2x plus cos x. Now which identity I need to solve this? Cos theta plus cos phi. So let's apply that. Cos theta plus cos phi, which will be 2 cos theta plus phi by 2 cos theta minus phi by 2. So 2 sin x, and it will be 2 cos theta plus 5 by 2. 2x plus x by 2. And cos theta minus 5 by 2, that is 2x minus x by 2. So 3x by 2 it will become, and this will become x by 2. So let's rewrite them. 2 sin x, 2 cos, 3x by 2, and cos x by 2. 2 to the 4, and that's it. That's what we have to prove. 4 sin x cos 3x by 2 and cos x by 2. And now we are going to solve some very important sums. Mostly in exams they are be asked for the 6 marks. So we have to find the values of sin x by 2, cos x by 2 and tan x by 2 when tan x is equal to minus 4 by 3 and x lies in the second quadrant. Okay, let's start. So x lies in second quadrant means that is pi by 2 to x lies up to pi. Second quadrant is from pi by 2 to pi. If x lies in second quadrant, then x by 2 will lie in, if I divide this equation by 2, then it will become pi by 4, x by 2 and pi by 2. So that means x by 2 will lie between pi by 4 and pi by 2, which is in the first quadrant. That means all the t ratios having the angle x by 2 will be in the first quadrant. So my sin x by 2, cos x by 2 and tan x by 2 all will be in the first quadrant. So they will be positive only. Okay, that much we derived, that the value sign of all these three t ratios, sin x by 2, cos x by 2 and tan x by 2 will be positive. Let's proceed. Now to find out these values, what I will do, I will find out the cos x and I will apply some multiple formulas. So that will make my task easier. If I can find out cos x, then I can easily find out sin x by 2, cos x by 2 and tan x by 2. So let's start. So for converting tan x into cos x, what I will do, I know an identity that 1 plus tan square x is equal to sec square x. Now put the value, tan x is minus 4 by 3, its square is equal to secant square x. So it will be 1 plus 16 by 9 is equal to secant square x. 1 plus 16 by 9 will be 25 by 9 sec square x. And 25 by 9, if I do the square root, then it will become plus minus 5 by 3. And if I know the secant x is plus minus 5 by 3, so where is x? X is in the second quadrant. So if my x lies in the second quadrant, so in second quadrant secant will be negative. So x lies in the second quadrant, so secant will be negative. So that is secant x is equal to minus 5 by 3. And if I know secant, can I find out cos? Yes, reciprocal of secant, that is minus 3 by 5. Now, as I promised, if once we got the value of cos, what we will do, we will apply the submultiple formulas. So cos x is minus 3 by 5, and we know that 2 cos square x by 2 minus 1 is equal to cos x. See, this cos 2x is equal to 2 cos square x minus 1. And if I am taking cos x, then cos x will be 2 cos square x by 2 minus 1. So that's what I put here, 2 cos square x by 2 minus 1. So we have to find the value of cos x by 2. So take all the terms to the other side. 2 cos square x by 2 will become minus 3 by 5 plus 1. This minus 1 will become plus 1. And if I simplify them, it will become 2 by 5. 2 and 2 cancel, 1 by 5. So cos x by 2 will be plus minus 1 by root 5. Now we cannot have two values as x lies in first quadrant. So cos x by 2 will be positive only. So we'll discard the negative value and our answer will be cos x by 2 is equal to 1 by root 5. To get the value of sin x by 2, I can apply sin square x by 2 plus cos square x by 2, or I can use the same type of identity that cos x is equal to 1 minus 2 sin square x by 2. So here I am going to apply this one. So cos x is 1 minus 2 sin square x by 2, which is equal to minus 3 by 5. To get the value of sin x by 2, take all the terms to the other side. So minus 2 sin square x by 2 will be equal to minus 3 by 5 minus 1, which is minus 8 by 5. See, minus and minus cancelled. 2 4 are 8. So sin x by 2 will become plus minus 2 by root 5. And as x by 2 lies in the first quadrant, so we will take only positive value. Our sin x by 2 will be equal to 2 by root 5. So as you know, tan x by 2 is sin x by 2 upon cos x by 2. And what is the value of sin x by 2? 2 by root 5. And cos x by 2 will be 1 by root 5. So if I simplify them, this will be cancelled. So value of tan x by 2 will become 2. Next is we have to find the value of sin x by 2, cos x by 2 and tan x by 2, and it is given that cos x is minus 1 by 3. So this is an easy part because cos x is given, so no need to run to find out the cos x. So as x lies in the third quadrant, that means the value of x is from pi to 3 pi by 2. Okay, divide by 2 so that I can get x by 2. If I divide every term by 2, it will become that x by 2 will lie from pi by 2 to 3 pi by 4. That is quadrant number 2. From pi by 2 to 3 pi by 2, 4 is in the quadrant number 2. And in second quadrant, sin x by 2 will be positive, and the remaining two t ratios, that is cos and tan, will be negative 1. So here we decided that value of sine will be positive and value of these two terms will be negative. So let's find out. Cos x by 2 is minus 1 by 3, and as we know that cos x is 2 cos square x by 2 minus 1 is equal to minus 1 by 3. Take this minus 1 to the right hand side. It becomes 2 cos square x by 2 minus 1 by 3 plus 1. So 2 by 3. And if I cancel with 2, it will become 1 by 3. So cos x will be plus minus. So cos x by 2 will be plus minus 1 by root 3. As x by 2 lies in second quadrant, so we'll take it negative. So minus 1 by root 3. So this is the value of cos x by 2. So let's find out sin x by 2. So cos x is minus 1 by 3. So 1 minus 2 sin square x by 2 will be equal to minus 1 by 3. Take this one that side. It will become minus 2 sin square x by 2 is equal to minus 1 by 3 minus 1, which is minus 4 by 3. So minus and minus cancelled. 2 2s are 4. So sin square x by 2 will be 2 by 3, and I can say that sin x by 2 will be plus minus root of 2 by 3. As x by 2 lies in the second quadrant, so sin x by 2 will be positive. So answer will be root of 2 by 3. Now can we find out tan x by 2? Yes. To find out tan x by 2, what can we do? Sin x by 2 divided by cos x by 2. Sin x by 2 is root of 2 by 3 and cos x by 2 is minus 1 by root 3. So root 3 cancelled. So minus root 2 is the answer. Our next sum is sin x is given 1 by 4 and x lies in second quadrant. So when I say that x lies in second quadrant, it means that value of x is from pi by 2 to pi. And if I divide by 2 all the terms, I will get pi by 4, x by 2 and pi by 2. That is, x by 2 lies in the quadrant number 1. So in first quadrant, as we know, all three t ratios, that sin x by 2, cos x by 2 and tan x by 2 will be positive. So now let's find out the value of cos x, so that will help us to get all these values. From sin x to we will convert into cos x. As we know that sin x is 1 by 4 and 1 minus sin square x is equal to cos square x. What is the value of sin x? 1 by 4. So let's put the value of sin 1 by 4. So 1 by 4 square is equal to cos square x. 1 minus 1 by 16 is equal to cos square x. And on simplification, 15 by 16 is equal to cos square x. and the value of cos x will be root of 15 by 16 plus minus. So cos x is in the second quadrant, and in second quadrant cos will be negative. So as x lies in the second quadrant, so cos x will be negative. So what will be my value of cos x? Minus root 15 by 4. So cos x is minus root 15 by 4, and as I know that cos x can be written as 2 cos square x by 2 minus 1, and which is minus root of 15 by 4. So if I take this minus 1 that side, right hand side, minus 1, so it will become plus 1. And if I take the LCM, it will become 4 minus root 15 by 4. And if I take 2 also this side, it will become 8. So cos square x by 2 will be 4 minus root 15 by 8. So cos x by 2 will become plus minus root of 4 minus root 15 by 8. So we will take the positive value, which will be root of 4 minus root 15 by 8. So now let's find out the sin x by 2. Cos x is minus root 15 by 4, and it is 1 minus 2 sin square x by 2, which will be root of 15 by 4. So let's simplify this. So first of all, I'll take this plus 1 that side, it will become minus 1. And if I take the LCM, so it will become minus if I take common. So 4 plus root 15 by 4. So minus and minus we will cancel. So sin x by 2 will become, and 2 will become this side by 8. So value of sin x by 2 will be root of 4 plus root of 15 by 8. And to get the value of tan x by 2, what we will do? We will divide sin x by 2 divided by cos x by 2. What is sin x by 2? Root of 4 plus root 15 by 8 and divided by root of 4 minus root 15 by 8. So 8 and 8 cancel root inside root, and that will be our answer, which can be rationalized later. So if you want to rationalize, you can, and final answer will become 4 plus root 15. So that was all about today's video. Hope you enjoyed this. Thank you very much for being with us. If you have any query, you can write to us.